All right, are you ready to take notes today? You got your paper and pencil? I'm Mrs. Cohen, and today we're talking about word problem inequalities. Now, when you're solving inequalities in word problems, you have to look for key phrases. And here are some of the phrasing that you'll see sometimes that keys you in that this is an inequality and it has more than one or two values. You might see something in the description of the word problem that it says it's less than. It might say it's less than or equal to. Is at most. Is at least. Is greater than or equal to. So that means it could be greater than, or it could say it's greater than or equal to. But then means you have both greater than and an equal to sign to it. So today we're going to start with this word problem. The sum of three consecutive integers is less than or equal to 18. Great. Now we need to learn how to pick that word problem apart and look for key phrasing. Let's look. Well, look, it says that it's less than or equal to. So we're going to underline that. So we know we have less than or equal to. And we know that it's 18. The next key thing is it says the sum of, so we're adding, of three consecutive integers. So we've already identified the number system, the set of integers, which are whole numbers and their opposites. So we're not talking about fractions and decimals. We're talking about the set of integers. That's the only number system we're dealing with. So we want to somehow note that so we don't forget that when we do our graph. And it tells us it's consecutive. The best thing to do sometimes is simply to stop and think, what are three numbers that are consecutive? Three integers. 3, 4, 5. Then you say, okay, we're not going to use three different variables. We're going to use one variable, and we're going to build off of that to make three unknowns. So if we say x is the first integer, x is the first integer, and in our head we say, that's 3. Well, how do I get to the next consecutive integer, which is 4? How do I get from 3 to 4? Oh, I add 1. But then I have to say, when I'm thinking outside the box, so I know that I have to add 1 to this. X plus 1 is my second integer. Well, what's my third integer? Well, I said 3, 4, 5. 5 is my third integer. But I don't say, how do I get from 4 to 5? I say, how do I get from 3 to 5? Because 3 is my variable. So how do I get from 3 to 5? I add 2. So I go back and I say x plus 2 is my third integer. Now remember, this can be called a legend or labels. Some teachers, well, I expect you to write the labels or the legend. So you identify what you're looking for. Now, some teachers like you to write x plus the quantity of x plus 1 plus the quantity of x plus 2 with parentheses so you can show the three different numbers. I don't mind. I don't care if you do that, or, let's bring this down a little bit, if you say x plus 1 plus x plus 2 is less than or equal to 18. Now, some of you may want to include the parentheses. It'll help you organize your information. So now we just solve it like we do a basic equation. Sometimes students want to move everything over and start trying to move this 1 and the 2 separately. So they're going to subtract 1 from both sides and then subtract 2. You're looking for a headache because you're going to make some careless mistakes. The best thing to do is to simplify each side of the inequality first by adding like terms. So this is going to be 3x plus 3 is less than or equal to 18. We're going to subtract 3 from both sides, get 3x is less than or equal to 18, divide both sides by 3, x is less than or equal to 5. Piece of cake. You want to work like I did. You want to write while you're thinking. You don't want to have to think about it and then write it. Train your brain to write while you think. It'll save you time on tests, and your brain will start recognizing the patterns for you. Now, we have to create a number line. Now Now I'm just going to start with 5. I'll put 4 here, 6, 7. It says x is less than or equal to 5. Well, let's see if that's true. That means the greatest that x can be is 5. So 5 plus 6 plus 7. 5 plus 6 plus 7, if we plug it back in, is 18. Because the highest x can be is 5. Because I'm going to add 1 and then I'm going to add 2 to it. So you can't say that x is 7 because then it would be too great. It would be 7, 8, 9 and that's going to be greater than 18. So 5 is what x has to be, and we're defining the inequality based on x. So when we come over here, we're not saying that 6 and 7 can't be added. We're saying that x, the greatest value that x can be to make this inequality true, is 5. Now remember, it was the set of integers. So when we show our solution on the graph, they are closed dots on the integers, and then we're going to have a solid line, well, a solid arrow, not a line, showing our pattern, and above this or below this, we're going to say x is less than or equal to 5. Okay? Remember, we're defining the value of x. It's okay that it's 6 plus 7. That's not part of the solution. At 5 is the highest number, the highest integer that x can be. All right. So now let's go to the next one. You like that? Woo! I'm getting better at this. All right, this one is talking about shapes and figures. The perimeter of the rectangle is at most 36 centimeters. Again, let's take this, let's look at it. Let's pick it apart. At most. All right, so we know it's not equal to, or is it? That's right. It is, because it tells you it's at most 36. So it is equal to it. All right? And we have two, I don't know if you can see it, but the length is the quantity of 2x minus 13. And the width is the quantity of x minus 5. And that's centimeters. So we are going to start with identifying our formula for perimeter. P is equal to 2 times the length plus 2 times the width. Now, I'm going to identify that the length is equal to the quantity of 2x minus 13, and the width is the quantity of x minus 5. Now I'm going to plug it in. When I plug it in, I'm going to do a little role reversal here, and I'm going to say, okay, I like to work left to right, so I'm going to put the P on the other side, because it tells me it's at most. So that's the greatest value that the perimeter can be. So less than or equal to 36. And then I have 2 times the quantity of 2x minus 13 plus 2 times the quantity of x minus 5. Again, we want to make our life easier. We want to simplify both sides of the inequality first. We don't want to try to add or subtract or divide. So we got to do distributive property. So we get 4x minus 26 plus 2x minus 10 is less than or equal to 36. We get 6x minus 36 is less than or equal to 36. We're going to add 36 to both sides. 6x is less than or equal to 72. Notice there's no negatives I'm dividing by here. I'm not dividing by a negative. So my signs don't flip. Alright, so I divide both sides by 6, and I get x is less than or equal to 12. Remember, if I plug in a 12 here and I get 24 minus 13, okay, we'll do that in a second. We'll go in and plug it in and show you its work. So now we're going to do a number line, and it's less than or equal to 12. But it doesn't say integers. So you have to assume this is the real number system. So here we're going to have a closed dot on the 12 and a solid line going to the left with the solution above it, x is less than or equal to 12. Now, let's go back and let's plug in a 12. See what happens. 2 times the quantity of 2 times 12 minus 13 plus 2 times 12 minus 5 is less than or equal to 36. So this is 24 minus 13, which is 11. And this is 12 minus 5, which is 7. And then we get 22 plus 14 is less than or equal to 36. 36 is less than or equal to 36. Do you see the pattern? You are solving for x to see what it takes for x to be equal to the value of the inequality. Then if it's an equal to, less than or equal to inequality, then that means that x is inclusive. X is equal to 12. If it's simply less than or greater than, then it'll go all the way up to it to satisfy it, but it won't be equal to it. So all you're doing is you're solving an equation for the variable, but it's an inequality. And you have to recognize that you are actually solving for x to see what makes it equal to the value. Review your notes. Come up with two things that you learned about solving word problem inequalities, and then bring in one question you have about word problem inequalities. Have a great evening.